splitting this up into 3 days. Remember I said because some of the problems can get kind of long. So today we're going to learn about De Moivre's theorem. So we can use this to find powers. And I did add an extra E in there, so we're just going to cross that off. Okay, right here. I crossed it off here too. So if you have a Z value is the R times the cosine plus the I sine of theta. Well, first, what is this? What is this form? There are two names for it. Polar form or trigonometric form. Okay, now remember that that represents what type of number? Imaginary. Okay, so these are for imaginary or complex numbers. Then for any integer n, you can use De Moivre's theorem, which is z to the nth power equals r to the nth power. So whatever is your n here, it's also going to be the exponent on r. Where else is it? Okay, so it's in front of both of your thetas, right? So you're going to have to multiply that by theta. Well, let's think about why this would be helpful. So we're going to look at A and B. So the first one, we have 1/2 plus 1/2 I to the 12th. Now, I could find that without De Moivre's theorem. What would I have to do? I'd have to expand it, right? Using what? You could, yeah. Okay, you could do binomial expansion. Or if it's to the 12th power, you could write it out 12 times and then FOIL, right? FOIL, distribute. Basically, it would be a lot of work. Okay, so instead of doing all that, all we have to do is use De Moivre's theorem. So thank you, De Moivre. So for A, it says step 1, convert to polar form. So if we're going to convert that to polar form, we're finding two things, your R and your theta. So to find R, we use what equation? Well, R equals the square root. Remember with this, we do the A squared plus B squared, just because it's in polar form. And then we're going to use the tangent of theta equals B over A. Well, in this case, remember it's A plus BI. So my A and my B are the same. So if they're the same, then I just have the tangent of theta is equal to what? 1. 1/2 divided by 1/2 is going to be 1. And then you have to find where the tangent is 1, but in the same quadrant as your point here. So if it's positive, positive, we have to find this in what quadrant? In quadrant 1. Okay, so in quadrant 1, so we know that theta is going to be pi over 4. Okay, now for r, if we do 1/2 squared plus 1/2 squared, 1/2 squared is just what? 1/4. So 1/4 plus 1/4 is 1/2, right? 2/4, which is 1/2. And then we can just rationalize. The square root of 1 is 1. 1 over root 2. We can multiply the top and the bottom by root 2. So we'll get root 2 over 2. That's my R value. Okay, so then my polar form would be root 2 over 2. The cosine of pi over 4 plus I sine of pi over 4. Okay, so now I'm going to apply the theorem. So the theorem says if I'm trying to find to the 12th power, okay, so your z is your imaginary number, so z to the 12th would equal root 2 over 2 to the 12th. And then the cosine, we are going to simplify, yeah. So the cosine of 12 times pi over 4 plus I sine, and I'm just going to write this one as 12 pi over 4 like this. Okay, so I am going to simplify. So when I'm simplifying here, I have root 2 over 2 to the 12th. So I can do root 2 to the 12th power over 2 to the 12th power. Now you are going to be able to use your calculator for these, but I want to show you how you can do it without it. So if you have root 2 to the 12th, that's going to be the same as what? It will be 2 to something, but it won't be to the 10th. So root 2 times root 2 is what? 2. How many times is that going to happen if I have it 12 times? 6, right? So on the top it would be like 2 to the 6th, which is what? Or what's 2 to the 5th? That's something you should know right away. 2 to the 5th. 32. So 32 times 2 is 64. Okay, so if I have 2 to the 12th, isn't 2 to the 12th just 2 to the 6th times 2 to the 6th? Yeah, so wouldn't that just be 64 times 64? And then what could reduce? Yeah, so then this would be 1 over 64. Okay, that's what you are going to have. Now, if you did just use your calculator, when you did that on your calculator, what you would get is 64 over 4,096. Okay, so if you did that, you're still going to have to reduce. I recommend just trying the top number. See if 64 goes in there. We already know it does because of the work that we did here. Okay, so that's just something to think about. So we have 12 pi over 4, which is going to reduce to what? Yeah, 3 pi. So 3 pi plus I sine of 3 pi. And then from here, we are going to simplify and substitute in values. So simplify and substitute. Right, so we already said we know that this is going to be 1 over 64. Now for 3 pi, think of your unit circle. Right, 1 time around is 2 pi, so 3 pi is going to be the same place as what? Pi. So 3 pi is going to be here, which that point is negative 1, 0. So for cosine, I'm going to be plugging in what? Negative 1. And then it'll be plus I, and then the sine of 3 pi is 0. That's my y coordinate. Okay, so then I times 0 is just going to be 0. So this is negative 1 over 64, and that's going to be your final solution, is negative 1 over 64. Okay, so now I want you to do part B. So really you should be able to do all of part B. Again, you are going to simplify it down as much as possible. Your final answer will be written in the form A plus BI. Alright, so we'll check in. You guys can keep going. Just double check to make sure you have everything correct. So your tangent of theta was negative root 3 over negative 1, which would just be the tangent of root 3. But remember, this has to be in quadrant 3. So in quadrant 1, where is the tangent root 3? Pi over 3. So to find the one that's in quadrant 3, all I have to do to pi over 3 is what? Add pi. So pi over 3 plus pi is going to be 4 pi over 3. Okay, and then your r is going to be the square root of negative 1 squared plus negative root 3 squared. So that would be 1 plus 3. So the square root of 4 is going to be 2. So then you can just write that as 2 cosine of 4 pi over 3 plus I sine of 4 pi over 3. Alright, so now when we go to de Moivre's theorem, we are trying to find the fifth for this one. So this would be 2 to the 5th. And then the cosine of 5 times 4 pi over 3, which is going to be what? 20 pi over 3. Alright, so then this will be 32. And then we're going to find where 20 pi over 3 is. So to do that, again, we think of our unit circle. What I would do, so I don't have to count out 20, is figure out how many times around I can go pi over 3 in one rotation. And one rotation, it'll be what over 3? 6 pi over 3, because 6 pi over 3 divided by, or 6 pi divided by 3 is 2 pi. So if I'm at 6, and then I go around again, and then I'm at 12 pi over 3, I go around again, I'm at 18 pi over 3, so then I'm at 19 pi over 3, and then here is where 20 pi over 3 is, which really, that's the same spot as what? 2 pi over 3. Okay, so we can use our reference values. So here, I know that this is going to be root 1/2 root 3 over 2. So if I'm finding this point, I know that's going to be negative 1/2 root 3 over 2. Okay, so then I can just plug that in. So the cosine of 20 pi over 3 is going to be negative 1/2 plus I, and then the sine is root 3 over 2. Now don't get rid of your I. The last time it was 0, so we were able to multiply that out. Actually, sorry, I'll make them both like that. All right, and now we distribute. So 32 times negative 1/2 is negative 16. If you were to multiply this, you could write it as 32I root 3 over 2. And again, you can simplify that. Okay, so negative 16 plus 32 divided by 2 is 16. And you could either write it like this, or you could write it as negative 16 plus 16 root 3I. Right? Either one of those would be acceptable. I said either one, get it? Alright, and then I'm going to give you some time today to work on your homework.